So let's simplify 10 divided by root 7 minus root 2. What we previously talked about was the use of conjugates, and we can use conjugates to simplify these quotients whose denominator has a sum or difference of radicals. All right, so what that means is we have a denominator of root 7 minus root 2. So what we can do is use the idea of the conjugate, which was adding and subtraction combination of two numbers. In this case, they are radicals. And what we will do is then multiply by the conjugate. The conjugate of root 7 minus root 2 will be root 7 plus root 2. All right, the first terms stay the same, and the second terms are opposites. But I'm going to multiply it over itself because that is a version of 1. If we multiply this by 1, the value will not change. It'll look different, but the value will be the same. All right. So now I'm just going to rewrite it down here, and that'll give us 10 times root 7 plus root 2 over, put it in parentheses, root 7 minus root 2 times root 7 plus root 2. Right. And as we previously stated, when we multiply conjugates together, their product is a difference of squares, meaning if I take the first term and square them, root 7 times root 7 gives me root 49, or just 7. And the second terms, root 2 times root 2 gives me root 4, or 2, and it will be a difference of them. What will happen, as a reminder, the middle terms, root 2 times 7 and 7 times root 2, they will cancel each other out. So we're just left with the first two numbers and the last two numbers squared, minusing. All right. And in the top, we have still root 7. Oh, forgot a root sign up there at the beginning. My apologies. You probably caught that. That should be root 2. Root 2. All right. And this now equals 10 root 7 plus root 2 over 7 take away 2 is 5. And now what I could distribute this, but if you look, I can simplify 10 over 5. 10 over 5, just like a regular old division problem, is just 2. All right, so I'm going to rewrite it down here as 2 times root 7 plus root 2, which will equal 2 root 7 plus 2 root 2. All right, there we go.